Expression genes. For differential expression genes calculation, we often use the fold change, t-test, ANOVA, R in the lemma, and the Fisher exact test. So what is a fold change? Fold change is to calculate the log ratios between the two different groups. We use the TCGA data as example to show how to calculate the fold change and the t-test in Excel. So this is a data set from the TCGA breast cancer patient data, and here it is a lumin A subtype, and this is a basal-like another subtype, and each of the row that means for one genes, and the middle that is gene expression. We want to calculate between the lumina A and basal-like what is the difference on each of the genes. We want to check about lumina A and basal-like what is different. The fold change is to calculate the ratio based on the means of the lumina A and divided the basal-like average. So the fold change, the calculation is the average, AVERAGE average, such as this genes, average, and this first group, and divided the second group is the average. This is the basal-like. Click enter. So all the formula in the Excel is start is based on the equal and give the average the first group, and here it is the average the second group. That is the use the ratio of the means. For Excel, we can copy all the formula from one cell to the other cell. We can say this mouse, when we move your mouse and around the handle, the fill handle is where between the solid add. Quick click the solid add is where copy the formula from the one cell to the other cells and to the whole cells. So you can see here. As two holes. Fold change is sometimes considered as meaningless. Is larger than two fold change is upregulation. If it is less than the two fold change is downregulation. That is without the statistical significance. It's based on the probability value from a t-test or ANOVA. To a biologist, the fold change is often they are very important two reasons. First is a very small but statistical significant fold change might not be relevant to a cell the functions. The second, it is of interest to know which the genes are most dramatically regulated, as they are often thought to reflect the changes in the biological meaningful transcripts and or pathways. So here it is to show the fold change, they are the same, but we can't to look at the variance, they'll keep the same. The fold change does not take the variations into account, such as here. Here it has two different groups, and they are keep the same average. So we look at, this is a small, we call it a low variability, and this is a middle variability. And here is the two groups, they are large variability. They are the same fold change, but we didn't look at the variations. They didn't give any test to show that is the change is significant or not. Statistical test, we call it is a t-test. T-test is a hypothesis testing. Here's a normal and this a tumor. They look at the differential expression gene and the means of the average. At the same time, they will look at their variations. So non-hypothesis, we think of their means of them, they are kept the same. Alternative hypothesis, we think of that is a difference. For t-test, the hypothesis that the two means are not the statistical difference. At the same time, to look at the variations. So they should be to look at the mean, standard variation, and the sample size, calculate the statistic. So they use a threshold, we call it as a cutoff, and to look at the difference if it is inner of this cutoff or it is larger than this cutoff. If it is larger than the cutoff, means they are significant, such as a p-value less than 0.05. That is very typical threshold. We think of the 95% the confidence as the mean for the genes between the control group, and another it is a treatment. Inferential statistics. T-test is inferential statistics. Inferential statistics are used to make an inference about a population from a sample. They based on the hypothesis testing. So they set up null hypothesis, such as there is no difference in the significant. The alternative hypothesis is that there is a difference. So we use a test statistic to decide whether to accept or reject the null hypothesis. For many applications, we set a significance level to a p less than 0.05. Such as here example, they test in the 5 different conditions, and each of the dot is a replicate comparison of the conditions 1 and the conditions 5. We can see here, this is a mean and this is a 5 means. They are so different, and variations if they're so different. So we have a strong confidence to reject the null hypothesis. We think of the comparison of 1 and versus comparison 5, there are difference. So the t-test is to assess the difference between the two groups. So setting the alternative hypothesis, they are so different. A null hypothesis, there are no difference. Numerate take the absolute value of the difference of the two groups of the means, and the denominator calculate is a noise. For the t-test, obtain the possibility value is p-value. So t-test assess the difference between the two groups. In R, you can use the t-test and to calculate the different two groups, such as here the t-test, and this is a group 1 value, this is a group 2 value. They will give you how big the distance of the two different groups. At the same time, they give their freedom values and their significant or not, that is the p-values. If it is significant, that means it's a p-value less than 0.05. For t-test is to look at the different groups, they give a significant or not. And in Excel, the t-test start is equal and the t-test. We click the first group and we select the second group. So here it has a one side and a one tail distribution and a two tail distribution. One tail distribution means it's only look at group 1 is large than group 2, or group 1 is smaller than group 2. If you look at the both, so you pick up that is two tail distribution. Here the parameter we pick up that is a two tail. Under the last parameter is setting is for pair, is paired wise or not paired wise. So here it is not match paired wise. So we pick up is a two sample equal variations. We look at the standardized variation is a homogeneous or is a heterogeneous. Here it is pick up. We hypothesize they are keep the similar standardized variation. After you fill in the t-test, the whole formula, and click the enter. So move your mouse. This is we call is a handle, a fill handle. When the mouse is changed to the fill handle, is changed to the solid, add, quick click, and this will copy the formula from one cell to the other cells. So this is a we call is t-test the p-value. This is p-value. To tell you is a significant or different. Folder change will tell you which one is larger than the others and how many times it is a large and a small. So such as here is a lumina A it is smaller than the basal-like at least 5 times. So significant or not is you can look at